Hello friends, welcome to the video lecture series of Engineering Mathematics 1. Today, in this video lecture, we are going to discuss some multiple choice questions, these MCQs on Taylor's and Maclaurin series. In order to save time, this formula I have written: f of x plus h is equal to fh plus x f dash h plus x square by factorial 2 f double dash h plus x cube by factorial 3 f triple dash h and so on. This Taylor series is in ascending powers of x. Means function f of x plus h is expressed in ascending powers of x. Ascending powers of x. And the same series is expressed in ascending powers of h now. This is h, this is x. Means in short, h is replaced by x and x is replaced by h. So these two are Taylor series. Once again, the Taylor series means expansion of any function of x plus h. H may be any particular, h is a parameter, h is a constant. The f of x plus h we express in ascending powers of x, and same thing, function of x plus h is expressed in ascending powers of h now. Yes, this is infinite series, this is infinite series. Yes, there are infinite number of terms in the series. The first three terms I have written, so you may write more terms also. Now coming to the Maclaurin series. The Maclaurin series is a special case of the Taylor series. Here, in series 1, this is series 1, series 2, if you put h equal to 0, f of x, I am putting h equal to 0, h equal to 0, h equal to 0. I mean, this is the Maclaurin series, and Maclaurin series is what? The function of x, only function of x we expressed in ascending powers of x. In ascending powers of x here. Now, one more Taylor series I am going to write. Okay, it is again the special case of the Taylor series. Here in 1, replace x by x minus a, replace h by a. Then f of x will be, because x is x minus a and h is a, if you add these two, so minus a and plus a will get removed, only x will remain, and replace h by a, replace x by x minus a, replace x by x minus a, and so on. So this is the Taylor series in ascending powers of x minus a, in ascending powers of this linear factor. This is the Taylor series in ascending powers of x. The same series in ascending powers of h, and the fx now. Here we, in both the cases, we have function of x plus h. Here, in these two cases, we have fx on the left hand side, function of x only. And this function of x, we have written in ascending powers of x minus a, ascending powers of x minus a. Now some standard expansion also I have written, e to the power x equal to 1 plus x by factorial 1, x square by factorial 2 plus x cube and so on. Sin x is this, cos x is this, sin hx, cos hx, tan hx. Okay. Here, this sin h is hyperbolic sign, And here in sin x expansion, the plus minus terms are alternatively being occurred. And in sin hx expansion, all the terms are same, but all the terms are positive here. The same thing happens in cos also, cos x and cos hx. Here, plus minus alternatively occurs, and here all terms are positive. Then tan x expansion is this one, log of x expansion is this, 1 plus x to the power, and this binomial expansion is this one, sin inverse x expansion. Okay, this is 2 into 4 into 5. 2 into 4 into 5, you can directly write 3 by 40 also. This is cos inverse expansion. and cos inverse x is what? Pi by 2 minus sin inverse x. Pi by 2 minus the expansion of sin inverse x here. 2 into 4 into 5. This is not factorial 5, it is only 5. Expansion of tan inverse x, expansion of sin h inverse x, expansion of tan h inverse x. Here also you can remember in this way. See, if you look at sin h inverse expansion and sin inverse x expansion, here all terms are positive in sin inverse x expansion. Here the terms are plus minus alternatively occurs. Okay, terms are same, all positive, here plus minus. Now tan h inverse x expansion is this one. In examination, so one of these formulae, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, out of this 17 formulae, the one of this may be asked in the examination. One of this may be asked in the examination. And all these expansions I have written directly, but all these expansion can be proved using Maclaurin series, because all the expansions are in ascending powers of x. All the expansions are in ascending powers of x. And on the left hand side, function of x is there. See, sin x, cos x, function of x. Means all these 17, 16, whatever the formulae are there, all these formulae are important. Okay, I recommend you to remember it. And if you don't want to remember, you can prove it by Maclaurin series. But I recommend you to remember all these formulae. Just very quickly, some problems on what Taylor's and Maclaurin series. See, and only MCQs we are going to discuss. First two terms in expansion of log 1 plus e to the power x by Maclaurin series is dash. Here, I have not written the options here. Okay, in order to save time, I have not written options. The 4 options will be given to you, and one of the options here to select in examination. See, we are expanding this function. Okay, you may be given any function in place of this. So let us denote this by fx. And remember, first two terms in the expansion I want. In MCQs, most probably, first two terms of the expansion will be asked in the examination. We are denoting it by fx. Immediately, you find f0. Put x equal to 0. Log of 1 plus e to the power 0. E to the power 0 is 1. 1 plus 1 is 2, means log of 2. Take derivative of fx. Derivative of log is 1 by that argument 1 plus e to the power x, and derivative of argument 1 plus e to the power x is e to the power x. And once you get f dash x, find f dash of 0. Put x equal to 0. E raised to power 0, 1 plus e to the power 0. E raised to power 0 is 1, and 1 plus e to the power 0 is 1. 1 by 1 plus 1 is 1 by 2. Okay, here e to the power 0 is what? 1 always. Okay, the f dash of 0 is 1 by 2, and f of 0 is what? Log 2. So how many derivatives will be required? So in short, just you can remember in this way, that we are finding value of f0, f dash 0, f double dash 0, f triple dash 0, f4 0. f4 0 means fourth derivative at x equal to 0. So we want two non-zero values for first two terms, including f0. See, first value of f at x equal to 0 is log 2, which is non-zero. F dash of 0 is also 1 by 2, non-zero. Then we can stop for finding the derivative, because this will give us two terms in the expansion. Now, by Maclaurin series, this is the Maclaurin series. Fx is this, f0 is this, then put value of f dash 0 is 1 by 2. That's all. This is the answer to this problem. This is answer to the problem. Now second problem. First two terms of the expansion of sec x. Okay, let us denote it by given function is fx, sec x, and immediately you have to find out the value of what? f0 also. f0 is what? Sec 0. and sec 0 is 1 because cos 0 is 1 and sec 0 is 1 by cos, means 1 by 1 is 1. F dash of x is what? Derivative of sec x is sec x into tan x, and once you get f dash of x, try to find out value of f dash of 0, put x equal to 0. So sec 0 into tan 0, and tan 0 is 0, therefore it will be 0. Sec 0 is 1, but tan 0 is 0. 0 multiplied by 1 will be 0. The first two terms of expansion I want. But what did I tell you? We want two non-zero f value. Means f of 0 is 1, this is non-zero value, accepted, but f dash of 0 is 0. Okay, on finding up to f dash 0, I will not get first two terms, If value of f dash 0 is 0, then try to find out f double dash of this, because f dash 0 is going to become 0. Now f double dash of x will be what? F double dash of x means derivative of f dash x. Derivative of f dash x. We are using product rule, u into v rule of the derivative. First function sec x, derivative of tan is what? Sec square x plus tan x, second function, and derivative of sec x is sec x tan x. Okay, and f double dash of x we have obtained. Now find f double dash of 0, and f double dash of 0 is what? This is sec 0 into sec square 0. You can directly write plus tan 0 sec 0 into tan 0. See, tan 0 is 0, tan 0 here I am writing, tan 0 is 0 and sec 0 is 1. Okay, so this will be 1 now, because tan 0 is going to become 0, f double dash of 0 we have. Now, this is non-zero term derivative we have. Now we have two non-zero f term. First non-zero term is 1 and next non-zero term is 1. Now here I look at first two terms, expansion containing first two terms. Now putting value of f0, f dash 0, f double dash 0 in Maclaurin series. This is Maclaurin series, I am not writing this Maclaurin series here because it is already displayed there. F of x is what? Sec x is equal to f0 is what? 1 plus x into f dash 0 is what? 0 plus x square by factorial 2. Factorial 2 means 2. Factorial 2 is 2. F double dash 0 is what? 1. In this way, 4 years, in this way, the series up to 2 terms I have written. Just you can put here dot dot. It indicates that a lot many terms are there. Okay, this right hand side is answer to this one. Means sec x we have expanded in ascending powers of x up to 2 terms. The same problem now. First 2 terms in the expansion of e raised to x sec x. Okay, so this is for you. This problem is for you. Denoted by fx. Take its derivative. Okay, if you then a value of f of 0 you will get. Take f dash 0 and f double dash 0. Okay, and first 2 values of f are non-zero. Then stop taking derivative. Now immediately the next one. This is third, now fourth. First 2, same problem. Now function is going to change. First 2 terms in the expansion of tan inverse of 1 plus x. Okay, what should I do? Let us denote it by fx. It is tan inverse of 1 plus x. Immediately put x equal to 0 and get the value of f0. Tan inverse of 1 plus 0 is tan inverse of 1 is pi by 4. This value of f0 we have obtained, and which is non-zero value. Just I am going to just highlight it. This is non-zero value. F dash x, now we try to find out derivative of fx means f dash x. What is derivative of tan inverse? It is 1 by 1 plus argument square, and derivative of 1 plus x is 1. This is f dash of x. Quickly, I am going to put x equal to 0 and I am going to find out value of f dash 0 like this, and 1 by 1 plus 1 is 1 by 2. See, two non-zero values of f we have obtained. Just you stop taking derivative now because we are interested in first two terms of expansion. Now in Maclaurin series, what is the Maclaurin series? Fx equal to f0 plus x f dash 0 plus x square by factorial to f double dash 0, and like this. The fx is tan inverse of 1 plus x, okay, and f0 is what? It is pi by 4, and x f dash of 0 is what? 1 by 2, plus and so on. Okay, this is the answer to this problem. We have expanded tan inverse x in ascending powers of x up to 2 terms only, up to 2 terms, because in MCQs the question will be asked up to 2 terms. If 3 terms are required, the f double dash x will be required, that's all. If 4 terms are required, f4 0 will be required, means fourth derivative of fx will be required. Now same problem again, first 2 terms in the expansion of sin x by 2 plus cos x by 2. See, here you can use the standard expansions also. You can use the formula of sin x, expansion of sin x, expansion of cos x to infinite series. You can add and you can solve it. Okay, I am going to solve it by Maclaurin series. Okay, fx is sin x by 2 plus cos x by 2. Put x equal to 0, sin 0 by 2 means 0, cos 0 by 2, cos 0 is 1, sin 0 is 0, this value of f0 is 1, that is accepted because it is non-zero value. Now f dash x means derivative of fx. I have to take f dash x, derivative of fx is what? Derivative of cos, sin is cos x by 2 into 1 by 2, and derivative of cos is what? Minus sin x by 2 into 1 by 2. Put x equal to 0. If you put x equal to 0, f dash of 0 you will get, and cos 0 is 1 means 1 by 2 will remain, sin 0 is 0 means 0, means 1 by 2 is f dash 0. Again this is non-zero value. If first two value of f we get as non-zero values, then we stop taking derivative. Now putting this in Maclaurin series, this is Maclaurin series. Fx is what? Sin x by 2 plus cos x by 2 equal to f0. f0 is what? 1 here. X into f dash 0 plus x into f dash 0 is 1 by 2. First 2 terms we want, that's all. Okay, this we will not bother about the sign of third term, If you put dot dot, it indicates that infinite number of terms are there and those terms are hidden. Now the expansion of log of 1 minus x to the power log of 1 minus x to the power 4 minus log of 1 minus x. Here you can solve this problem by Maclaurin series or direct expansion method also. Here this problem also can be solved by direct expansion method. So you can use direct Maclaurin series here, but I am using here direct expansion of log of 1 minus x. Okay, see the formula I am writing, log of 1 minus x formula. Okay, in the beginning I just shown you what is log of 1 minus x. See, log of 1 minus x formula, where it is log of 1 plus x, and log of 1 minus x will be what? Replace all x by minus x. Replace all x by minus x. You will get the formula for log of 1 minus x, means in this way. Log of 1 minus x equals minus x whole square means plus, like this, x cube by 3 and so on. Okay, all negative, plus minus here in this case, here all negative. See, now the expansion of log of 1 minus x, means this I am going to use here, expansion of log of 1 minus x. The expansion of log of 1 minus x is what? See, log of 1 minus x to the power 4. Okay, the first two terms I will be writing. See, or you can write 3 terms also. Log 1 minus x expansion, log 1 minus x to the power 4 expansion. Replace x by x to the power 4 like this. Replace x by x to the power 4. Replace x by x to the power 4. Okay, x to the power 4 raised to power 3 by 3 you can write. So I am not writing it. That term is there. This is the expansion of log of 1 minus x to the power 4. What is the expansion of log of 1 minus x? Expansion of log of 1 minus x is what? Minus x square by 2 minus x cube by 3 minus x to the power 4 and so on. Now we want expansion of log of 1 minus x. Log of 1 minus x to the power 4. I am going to consider it. What I am going to consider? Log 1 minus x to the power 4 minus log of 1 minus x. Now expansion of this I am writing in this bracket, and expansion of this I am writing in this bracket. Okay. So 1 minus x to the power 4 is what? Minus x to the power 4 minus x to the power 4 raised to 2 means x to the power 8. Okay, higher power terms are there. Here log of 1 minus x minus x square by 2 minus x cube by 3 minus x to the power 4 by 4 and so on. Okay, this is expected in the examination. Okay, this will be in the option, But why did I write up to x to the power 4? There are many terms, but I know here this series, infinite series, starts from x to the power 4. That's why I have written up to the x to the power 4. Okay, so you may add these two series. How do you add this series? This infinite series, this infinite series. I am going to add. So how the infinite series are added? To write down the terms of x, okay, with respect to its power, means minus x. Okay, this is the lowest power term. Next minus plus, this is next to the lowest power x square term. If x cube term is there, yes, x cube term is there. X to the power 4 term is there. Okay, here here also x to the power 4 term is there. Then x to the power 5 term is there, x to the power 6, x to the power 7, like that. Okay, now x plus x square by 2 plus x cube by 3, and you can add these two. 1 by 4 minus 1 is what? Minus 3 by 4. 1 by 4 minus 1 is what? Minus 3 by 4 x to the power 4. Okay, this is the expansion of log of 1 minus x to the power 4 minus log 1 minus x. Now the expansion of log of 1 plus x power x. What I am going to do? Just I am going to consider this function log 1 plus x to the power x. In examination, this x and this x may be replaced by any other thing. This x may be replaced by 1 by x, this x may be replaced by x square, x cube, this x may be replaced by 2x, 3x, 4x, like that. Okay. Now by law of logarithm, this x can be brought at the coefficient place. In this way I brought at the coefficient place. Then by direct expansion, log of 1 plus x can be expanded like this. This is log of 1 minus x expansion. in log of x expansion plus minus occurs alternatively. On the first page, just I have given you the formula for this. Okay. Now, this is infinite series, and each term must be multiplied by x square minus x cubed by 2 plus x raised to 4 by 4 by 3 and so on. Okay, this is the correct answer. This is the correct answer. Now, the expansion of cos 2x and cos 3x. Expansion of cos 2x and cos 3x. Yes, here I am going to consider sin 2x and cos 2x, cos 3x. See, all those problems can be solved by Maclaurin series also, or you can solve it by you can solve all those problems by using direct expansion also. Okay. See, this is the write down expansion of sin 2x, write down expansion of sin 3x, cos 3x. What is expansion of sin 2x? Expansion of sin x or sin y is what? Y minus y cubed by factorial 3 plus y raised to 5 by factorial 5 and so on. Expansion of cos y is what? 1 minus y square by factorial 2 plus y raised to 4 by factorial 4 and so on. So you can directly write it. Expansion of sin 2x will be what? Replace y by 2x minus 2x cube by factorial 3 plus 2x power 5 by factorial 5 and so on. Okay, here cos 3x expansion will be what? Replace y by cos 3x. Means 1 minus 3x power 2 by factorial 2 plus 3x power 4 by factorial 4 and so on. Now you can multiply these two. You can multiply these two series. Multiply this by 2x, multiply the same infinite series by 8x cubed by factorial 3 is 6. But in examination, this is expected. This is expected. It's coming to the next one. The simplified next problem is the simplified expression of this. This is 1 plus infinite series plus 1 by 2 raised to power 2 plus and so on. The simplified expression of this, how do you write it? See, I am writing directly. Simplified expression of this I am going to write. Here, 1 plus this infinite series and power of this bracket is what? Power of this bracket is 1. Okay. Power of this bracket is 1. X square minus x cube plus x to the power 4 plus x to the power 5 and so on. This infinite series. But here in this bracket, infinite series is present, but square of infinite series is there. Square of infinite series. And when you take the square of any bunch of terms, the square of, for example, square of a plus b is what? A square plus b square plus 2ab. Okay. The square of a plus b plus c whole cube containing at least cube of each term, and many more terms are there. Okay. Means square of this infinite bracket containing at least square of each term. See, square of x square is x to the power 4. Square of this will be this term x to the power 9 by 4 and so on. There are many terms. The only first term I have written. In MCQs, you will be given the answer up to 3 to 4 terms maximum. Now, see here there are many terms. Square of each term is there. X raised to power 4 is there. X to the power 9 by 4 is present. X to the power 8 by 9 is present. But those terms I have not written. Those terms are present. Now I am going to add these two infinite series. lowest term is 1, lowest degree term. Next power term is x power 2. Next term is x to the power 3 term, and next term is x to the power 4 term. But here x to the power 4 term, there are two terms, 1 by 3 and here 1 by 2, and there are many terms now again. Therefore 1 plus x square minus x cube by 2 plus 1 by 3 plus 1 by 2 is what? 5 by 6. If you take LCM as 6, you will get like this. Okay, this is the answer to, this is the simplified expression of this infinite series, and in each term, in each bracket, infinite series is again there. Now very quickly, first two terms in the expansion of log of sec x in ascending powers of x minus pi by 4. Okay, this is important. Here, now we are expanding function of x. This is a function of x. We are expanding function of x in ascending powers of x minus a, x minus h, or x minus a. Now the Taylor's, what is the Taylor's expansion? Function of x we are expanding in ascending powers of x minus a, f of a plus first two terms I want. X minus a power 1 by factorial 1, f dash of a, plus and so on. Only first two terms I have, first two terms. Now, what is a here? A is pi by 4. A is what? Pi by 4. A is pi by 4. A is pi by 4. F dash of pi by 4. Okay, if third term is required, then I will be writing it. Okay, first two terms I have written. If third term is required, I will be writing it. Now, here, see, f of x is what? Fx equal to what? Log of sec x. What is required here? F of pi by 4 is required. F of pi by 4. Put x equal to pi by 4. Log of sec pi by 4. And sec pi by 4 is what? Root 2. Cos pi by 4 is 1 by root 2. The sec pi by 4 is root 2. This f of pi by 4 is log of root 2. F of pi by 4 is log of root 2. Now, I want f dash pi by 4. For f dash, take derivative of fx. That is f dash x. Okay. What is derivative of log of sec x? Derivative of log of sec x is what? Tan x. Directly. Derivative of log of sec x is tan x. And f dash of pi by 4 is required. Tan pi by 4, put x equal to pi by 4, and tan pi by 4 is 1. The putting value of f dash pi by 4, which is 1, and f of pi by 4, which is log of 2. See, fx equal to log sec x. Separately I found value, I am putting here. F of pi by 4 is log of root 2 plus x minus pi by 4. F dash of pi by 4 is 1, and so on. Okay, this is the correct answer. We have expanded function of x, log of sec x, in ascending powers of x minus pi by 4. This pi by 4 may be replaced by any other constant. Okay. Now, same problem again. First two terms in the expansion of root of x plus h by Taylor series in ascending powers of h. Okay, when you solve problem, just get to know that what is expected. We are expanding this function in ascending powers of h now. This is h. Means this is x plus h function we are expanding in x plus h function we are expanding in ascending powers of h. Then what is Taylor series? By Taylor's theorem, what is the formula? F of x plus h means function of x plus h we have to expand in ascending powers of h. What is it? F of x plus h f dash x plus and so on. Okay, there are many terms, but first two terms I want. That's why I have written Taylor's expansion up to two terms. So what is required here? What is required? F dash of x is required. F dash of x is required. Separately I am going to find out. See, f of x plus h is root of x plus. This is x plus h function. Remember, f of x plus h function. F of x plus h is root of x plus h. Therefore, f of x will be what? Just you remove h from the right, both the sides. F of x is this. And what is required? F dash x is required. F dash of x, derivative of root x is 1 by 2 root x. Now putting value here, f of x plus h is root of x plus h, and fx is what? Root x, plus h into f dash x is what? 1 by 2 root x. To be expanded, given function in ascending powers of h now, up to two terms. Now, same problem, first two terms in the expansion of this one. See, if you look at this function very carefully, this function is f of x plus h function. Let f of x plus h is log of cos of x plus pi by 4. Okay. Expansion of first two terms, in expansion of this in ascending powers of x I want. See the difference between these two. Here we have expanded in ascending powers of h. Here we are expanding in ascending powers of x. Okay, what is the Taylor series then? Taylor series f of x plus h. Yes, why did I equate this with f of x plus h? Because we have x plus h factor. H is pi by 4. In ascending powers of x now. In ascending powers of x, how do you write? F of h. Replace x by h now. X into f dash of h plus and so on. Okay. Now here in this problem, h is what? H is pi by 4. Particularly in this problem, h is pi by 4. F of pi by 4 plus x into f dash pi by 4 plus and so on. Yes, what is required? F of pi by 4 is required and f dash of pi by 4 is required. Now, we are letting this one, we are letting this, and f of x plus h is what? F of x plus h is equal to what? Log of this one. Therefore, f of x will be what? Log of cos of x only. Okay. And what is required? F of pi by 4 is required. So put x equal to pi by 4. Put x equal to pi by 4. And cos pi by 4 is what? Cos pi by 4 is what? 1 by root 2. Okay, 1 by root 2 can be written like this also. Or you can keep as it is. And log of root 2 can be written as 1 by 2 log 2 also. So f of pi by 4 is required, f dash pi by 4. What is fx? Fx is this one. Take derivative of fx f dash x. Derivative of log of cos x is what? Yes, it is minus tan x. And put now, derivative of log cos x is minus tan x. Put x equal to pi by 4. Because we are interested in f dash pi by 4. Okay. Minus put x equal to pi by 4. Tan pi by 4 is 1. Minus of 1 into. Okay. So these two values, f of pi by 4 value you can put here. F dash of pi by 4 value you can put here. That will be your Fourier series. Okay. Now very 13th one. First two terms in expansion of this. In ascending powers of x, if you look at this function very carefully, here this is x plus h function, x plus h. Okay. So what I am going to do, let us denote it by f of x plus h. this is x plus 2 raised to power 5 plus 3x plus 2 raised to power 4. Okay, you don't forget that h is 2, and f of x will be what? Okay, you can write here f of x plus h like this also, h is 2. Then fx will be what? X raised to 5. Replace x plus 2 by x only. Replace x plus 2 by x, 3x to the power 4. Okay. Now we are expanding in ascending powers of x, and first two terms I want. The Taylor series I am writing. What is Taylor series in ascending powers of x now? See, f of x plus h is equal to f of h plus x f dash of h plus x square by factorial to f double dash of h, which is not required because up to two terms. Okay, we are interested. F of here h is 2 in this problem, h is 2 in this problem, h is 2. Okay, now what is the requirement of this series? f2 is required. So you can find out value of f2 by putting x equal to 2. Put x equal to 2. Put x equal to 2. 2 raised to power 5 is 32. 3 times 2 raised to power 4 is 16, you know. Then 48. 48 plus this is what? 80. Right? Now, what is required? F dash of 2 is required. Yes, for f dash of 2, take derivative of fx. F dash of x is derivative of x to the power 5. Derivative of this is 12x raised to power 3. And f dash of 2 is required. Put x equal to 2. 5 into 2 raised to power 4. 12 into 2 raised to power 3. Okay. Now this is equal to what? 2 raised to power 16 into 5, 80, plus 2 raised to power 3 is 8, and multiplied by 12. 12 into 8, 96. Okay, and this is what? 176. Putting those values here, f of x plus h means f of x plus 2 is this one. Okay, f of 2 is what? 80, plus x f dash of 2 is what? 176, plus and so on. There are many terms. Okay, this is the answer to this problem. What we have done, this we are expanding in ascending powers of x up to 2 terms only, up to 2 terms. Okay, now very quickly, next problem. First 2 terms in ascending powers of x in expansion of this. Okay, this problem and the previous problem is same. Here h is -1 only. H is -1. Okay, so this you try to solve at your own, this problem. The previous and this problem is same. Only +2 is replaced by -1. That's all. Now, first 2 terms in ascending powers of x minus 2. In ascending powers of x minus 2 now. X minus a type. What is the expansion? F of x, function of x. No? This is fx. In ascending powers of x minus 2, we are going to expand. And 2 is what? A. F of a plus x f dash of x minus a into f dash of a plus x minus a whole square by factorial to f double dash of a, and so on. Okay, we are interested in first 2 terms. Here fx is what? E raised to power x. In this problem a is what? 2. Here a is 2. F dash of 2. Infinite series up to 2 terms. And what is the requirement of this series? F2 is required, F dash 2 is required. Now f2 and f dash 2 I am finding here separately. Let fx equal to function e to the power x, and this implies f of 2 is what? Replace x by 2, e square. F dash of x is derivative of e to the power x is e to the power x, same. And f dash of 2, put x equal to 2, again e square. Okay, so put f2 is e to the power 2 plus x minus 2, f dash 2 is e to the power 2, and so on and so on. Okay, this is the correct answer to this problem. Next, first two terms in ascending powers of x minus 1 for the function tan inverse x. For the function tan inverse x. Okay, here I am going to solve it very quickly. Fx equals tan inverse x. The same formula, same formula. Then f, this implies here a is what? A is 1. Here a is what? 1. The f of 1, put x equal to 1, tan inverse 1 is pi by 4. Okay. F dash of x, derivative of tan inverse x is 1 by 1 plus x square. Here f dash of 1 is 1 by 1 plus 1 square means 1 by 2. Okay. And what is the formula? This is the expansion of function in terms of x minus a. So here this formula I am using. Fx equal to, here a is 1, here a, f of a, x minus a, f dash of a, plus and so on. Just putting values here, fx is tan inverse x. This is the expansion of tan inverse x in ascending power of x minus 1, and f of 1 is pi by 4 plus x minus 1, f dash 1 is 1 by 2. Okay, next problem. Next problem is of the, now here we have tan inverse x, here we have sin inverse x. Here we have a equal to 1, here we have a equal to 1 by 2. Okay, okay, this is for you. This is for you. And derivative of, hint I am giving, derivative of sin inverse x is what? 1 by under root 1 minus x square. And derivative of this will be what again? Derivative of this again, only hint I am giving. Hint I am giving. Derivative of 1 by, this can be written as 1 minus x square raised to power minus 1 by 2. And derivative of x to the power n, n minus 1, and derivative of argument 1 minus x square is minus 2x. We have to write. This 2 gets cancelled, minus minus plus x multiplied by 1 minus x square power minus 3 by 2. Okay. This is f dash of x, and this is f double dash of x. Okay, only one single derivative will be required. Single derivative will be required. Okay. If more than one derivative is required, maybe here in this problem 2 derivatives may be required. Because how many derivatives will be required? No, single derivative. This is for you. Now, first two terms in ascending powers of x minus 2. Here again a is 2, same thing, a is 2. Means what is the formula? Fx equal to, in ascending powers of x minus 2 I have to expand f of a plus x minus a, f dash of a plus and so on. Okay, this is Taylor series. What is function given to you? See here, what is function given? Let fx equal to 2x cube plus 3x square minus 8x plus 7. Okay, derivative of this f dash x is what? 6, 6x square, 6x minus 8. Now, f of 2 is required. So, what is f of 2? Here I am writing f of 2, instead of here I write f of 2 is what? 2 multiplied by 2 raised to power 3, 2 square minus 8 into 2 plus 7. Okay. Now try to simplify it. 8 into 2 is 16. Then 4 into 3 is 12. This is minus 16. This is plus 7. And this is 19. Okay. F of 2 is 19. F dash of 2 is what? Put x equal to 2 here. F dash of 2. 6 into 2 square. 6 into 2 minus 8. Okay. I am writing directly. This is 4, 24. 24 plus 12, 36. And 36 minus 8 is what? 28. Okay. This is f of 2. What is f of 2? It is 19 plus x minus 2. F dash 2 is 28. And so on. This is expansion of this function. This is expansion of 2x cubed plus 3x square minus 8x plus 7. In ascending powers of x minus 2 up to first two terms. Okay. And please remember, is all those sums I am taking here. But in the examination, the little bit changes you may find. You don't expect that the same sums will be there in the examination. Now, last two problems very quickly. Just only I am going to give the hint. Expansion of sine inverse function. Expansion of cos inverse function. In ascending powers of x, in ascending powers of x. When inverse trigonometric functions are present, here the derivative, higher order derivative will be very much difficult. So, what we'll do, we can substitute x equal to any suitable function so as to get the sign in this bracket. And once you get the sign in this bracket, sine inverse of sine, okay, of the domain will be the domain itself. Now, you know the formula. If you put x equal to tan theta, this formula we have 2 tan theta by 1 plus tan square theta is sine 2 theta. This is sine 2 theta formula. No? So what I am going to do, sine inverse of putting x equal to tan theta here, 1 plus tan square theta, and this is equal to, by formula, this sine 2 theta. Okay, anyhow, I have to bring sine here because outside sine inverse is present. Sine inverse and sine of 2 theta will be 2 theta only. And finally, theta is what? See, I am substituting x equal to tan theta. Here I am writing x equal to tan theta, I am substituting. And consequently, theta equal to tan inverse x. Okay, theta is what? Tan inverse x. And in the last step, put value of tan inverse x here. Tan inverse x value is given. See, 2 into this value. Okay, this is the answer. Expansion of tan inverse x here. Similarly, this problem, here, in cos inverse problem, you put down the value of x such that this bracket will be cos, because cos inverse is outside. Now substitute x equal to cos theta and theta will be cos inverse of x. It is very clear, inverse. Then cos inverse of this function, 4 cos cube theta minus 3 cos theta, is equal to cos theta. This is theta, no? This is theta. Then cos inverse of, this is theta. 4 cos cube minus 3 cos theta is what? Cos 3 theta. This is trigonometric formula. And cos inverse of theta will be 3 theta. And finally, you have to put value of theta, which is cos inverse of x. See, theta is cos inverse of x. And in the last step, the expansion of cos inverse x you can substitute. What is expansion of cos inverse x? Pi by 2 minus x plus x cubed by 6 plus 3 by 40 x to the power 5 and so on. Okay, this is the answer to the problem. Okay, this is the final answer to This is the expansion of this one. Okay. Now we stop here. Hope you understood it. Once again I am going to repeat. You don't expect that the same problems will be there in the examination. A little bit changes may be there. We stop here. Thank you very much.